Hey YouTube, I'm Sergeant Indy. Welcome back to my turn-based strategy tutorial for GameMaker Studio. This video, we're finally gonna do it. We're finally coding a basic artificial intelligence for our game. It's probably gonna be a long episode, so let's cut the formalities and dive right in. Let's create a new object. We're gonna call it OAI. We're gonna set its parent to actor. Now, AI is going to be the parent object of anything that uses our AI, our targets. So let's set our target, let's set its parent to AI, or object 34. Hold on, let's green check out of there, Let's make sure that that worked right. Okay, so what we have here, I'll get both of them open, is we have an inheritance chain. So our target will inherit all of its goodies from AI. AI will inherit everything from actor, so therefore, target will inherit everything from AI. It's pretty neat. So let's close this guy, and we're going to be cannibalizing a fair amount of code here, just sort of bouncing back and forth between our normal actor object and the AI, because a decent amount of the code is similar. So let's start by heading into actor, go into our step, and what we want is we want this initialized turn state. So let's go down to the bottom of that and copy all the way up to the top, because with this shake and the hit point stuff, all that's the same. We want all of that. Let's hit Control-C, green check out of here, green check out of our actor, add event, step event, drag in a block of code, and Control-V. Now at the end of here, we obviously need a squiggly. And then I need a bunch of room to work with, just in case, so I can try to keep working at the middle of the screen. Alright, so now in here, there's a bunch of stuff that doesn't matter anymore. This if army equals blue army, that'll never happen. This is our AI, it's just our bad guys. So let's get rid of all of this. Bloop. And at the end, our state, instead of going to state ready, we're going to make our state find target. Alright. So we still need this shake stuff at the top. We still need our hit points check. And then here's our initialized turn step. Great. Now let's work on that find target thing. So case find target. Colon. Break. Go up there, give ourselves some space to work with. Alright, so now what we're going to be doing here is pretty straightforward. We're going to take the node that we're currently standing on, the target is currently standing on, and we're going to go through its neighbors list to check every node adjacent to that node. If there's anybody standing there that's a hero, that's going to be our target. We'll move on to bopping them on the nose. Pretty straightforward. So, attack target. Come on, don't be cool. Attack target equals no one. And node equals map grid X. Grid Y, and so now we need to step through all of that node's neighbors. So for II equals 0, II less than DS list size, node dot neighbors, and II plus equals 1. Now, I just found out that apparently you can do II plus plus in GameMaker now. See, so I started learning how to code in C++, and this essentially means the same thing as plus equals 1. But I got in the habit of doing plus equals 1 because when I started using GameMaker a very, very long time ago, that was how you had to do it. But now apparently plus plus is fine, which makes me happy, but I'm going to go ahead and finish out the tutorial doing plus equals 1 because, well, makes the code uniform throughout all the things that we've written. So, we're going to step through all of the neighbor nodes. So let's go ahead and store whichever node we're currently going through in the neighbor variable. Make our code a bit cleaner. Neighbor equals dslist find value node.neighbors II. And then so if neighbor.occupant doesn't equal no one, so if there is someone standing on this node, then if neighbor.occupant.army equals blue army, so if they're a good guy, then attack target equals neighbor.occupant. Okay, so we'll step through all the nodes around us, grab ourselves a target if there is one, and then at the end here, we're going to do, let's scroll up. So if attack target doesn't equal no one, so if we do have a attack target, state equals begin attack. That probably sounds familiar. Action timer equals 10, probably also sounds familiar. And then else, state equals idle, flash equals true, and alarm 0 equals 30. Now remember, we don't need to code this alarm because this alarm is already in our target, so it'll be smart enough to just do it. Great, one less thing to worry about. And this is all pretty straightforward. We're going to step around, and if we can find a target near us, we're going to move on to begin attack and bop them on the nose. So let's go get begin attack and everything that follows it. So let's green check out of here. And let's open our actor back up. Head into this step. And we're going to grab everything from begin attack all the way down to quite a long trip to end attack. Control C. And if all of this goes away, it just means you hit X on accident. Just hit V or Control V, and it'll come back. Don't worry. Green check out of there, into our step, and right at the end here, straight back in. State equals idle. Hold on. Something went terribly wrong. I didn't get all of it. Well, whatever. End attack needs to be changed anyway, so let's change that now. Like, begin attack's fine, attack's fine. Pretty much, when you hit begin attack, whatever's on a begin attack, it's pretty much on autopilot, all the way straight to the end to end attack. I messed up my copy-paste. That's fine. We need to change it anyway. So, this if action timer is less than equal 0, that's fine. Everything else doesn't work. Bunch of hogwash. So let's go ahead and put that there. Hogwash, jeez. ogame.current actor equals no one. State equals idle. I probably haven't said hogwash since I was in the army. Break. Something I kind of started saying, I don't know, that's like as a joke. I started picking up a lot of random like Southern and British euphemisms, but saying them with a stock standard American accent because I think it makes it sound funny. Kind of like, what did you just say? Really? It's all 6s and 7s. Everything's gone pear-shaped. Okay, so when they're done attacking, I'm not really interested in them doing anything after that because what they want to do is be next to somebody and bop them with a stick. They don't want to, like, run away afterwards. So if they're there, if they've made an attack, they can go ahead and tell ogame current actor equals no one to move on to the next turn, set their state to idle. Done. Everything's done. So, let's run the game and let's see this in action. Green check out of here. Now, there's a pretty major problem with this code. Ugh. If this ever pops up, you just gotta put this back to Windows. I don't know what I did to change that, but I changed it. Oops. Okay. Like I said, there is something pretty major with this code, and we're going to see what that is. And let's put him here. Okay, so I'm going to have to hit X a bunch of times to demonstrate the problem here. So, now he's attacked whoever's standing in the top right. And he's going to keep attacking whoever's standing in the top right. So, what's wrong here? Well, what's wrong here is how our neighbor list is constructed. Let's go ahead and kill this out. Let's go into our ogame, create event. We'll see what the problem is. So, we're going through our neighbor list first to last every single time. And as you can see, we go left, right, top, bottom. Top left, top right, bottom left, top left. So, essentially, currently, we choose targets based on where they're standing in relation to our target. Let's head into AI to make things a bit clearer. AI step. we essentially just step through the whole list, and like so, we step through left. Okay, well, Sandy's standing there. Great, that's our target. Okay, right. Oh, well, Danny's standing there. Okay, well, never mind. Danny's our target. And every time we get to a new place that's got a new occupant, we just go, okay, well, this guy's our target now. And so our AI will prioritize who to attack based on where they're standing. That's not really a good way to set up an AI. So we want our AI to be a bit smarter than that, so we need to make our system a bit more complicated. So instead of altering our attack target variable directly, what we want to do here is we want to make a list of all of our adjacent heroes and come up with some ways of figuring out which hero to hit. So let's do that now. So right up here, attack target equals no one, node equals blah, blah, blah. So what we want here is a target list equals ds list create. Great. And then instead of just overwriting an attack target variable over and over, we're going to add them to this list. So ds list add target list neighbor.occupant. Great. And then in here, when we're done, we want to pick one. So if ds list size target list is greater than 0, attack target equals ds list find value target list. One of these days I'm going to type that right first try. Random range 0 ds list size target list, and then we want a -1, 2 of those, and we're done. All right, so let's get back. So essentially we're grabbing a list of everybody standing around us, and then we'll randomly attack one. Let's go in there, green check out of here. Let's run it. Let's make sure it's working. And this is pretty minor, and we're not done. If you guys don't want to run yet, I guess you don't have to. You can see it working on my screen just fine. Although maybe you should. Maybe you made a typo or something. It'd be a good idea to get in there and check. All right. So attack the one to the left. Great. Which, according to how our neighbor list works, we do our diagonals after our straight normal up, down, left, right. So we should have attacked this one. So we already know it's doing something. Let's make sure that it's continuing to attack randomly. All right, top. Great. Okay, so we know what's working. Let's kill this out. We said it's going to be a long episode. The less time we spend on demonstration, the better, right? All right, so when attacking a random target, it's better than prioritizing targets based on where they're standing in relation to where you're at, but it's still not a great system, so let's expand on things a bit. We'll make it so our enemies make a basic check with their intelligence statistic. If they fail, it means they lose their cool, and then they'll lash out randomly. But if they pass, they'll make a more intelligent decision, and they'll attack whichever target around them is the most hurt. Great. So, let's head back into there. And we're going to be find target right in this mess. So, neighbor document, no one, blah, 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 blah. Okay, so, in this part, let's just get rid of that. We're probably going to end up typing it later. But here, we want a bunch of other crap. So, roll equals irandom range 1 to 20. If roll plus int mod greater than 10. Health ratio equals 1. For II equals 0. II less than ds list size target list. Ooh, I did it right. Look at that. II plus equals 1. Temp target equals ds list find value target list II. Okay, so if temp hit points or temp target, if temp target dot hit points, if points divided by temp target, what was it? Max hit points less than health ratio, attack target equals temp target, health ratio equals temp target dot hit points divided by temp target dot max hit points. Okay, so what this is going to do is it's going to step through everybody in our target list, and then we're going to store them in here so we can do our simple looking code rather than having to type that all the time. So we're going to compare their current hit points to their maximum hit points, and that'll give us a ratio, a number between 0 and 1 of how many hit points they have remaining. So if that's less than our current ratio, which we set to 1, so if anybody's less than full hit points, like let's say Danny's at 80%. So, okay, so our attack target is Danny, and we're going to set our new ratio to 80%. So then we go to Sandy. Oh, well, Sandy's at 90. Never mind her. Oh, Sunny's at 40%. Oh, okay. So now our attack target is Sunny, and we'll set our new health ratio to 40, or not 40, 0.4. And then we get to Rizzo. Oh, Rizzo's at 50, so we'd ignore her. So we'll just sort of step through and sort of update health ratio and our attack target until we get to the one with the lowest hit points, and that'll be our attack target. So, great. So that's if our intelligence roll is greater than 10. So here we're going to do an else. I should have kept that thing. Attack target. We're going to do the same thing we did before, just randomly select one. So ds list, find value, target list, by random, range 0, ds list size, target list -1. And I just realized, what if nobody's below 1? Then we wouldn't end up with an attack target, would we? Maybe we'll put another case down here. Yeah, I just realized this is an issue. So we'll do our roll. And if we fail the roll, we'll do that. But if we get through here, like if everybody's at full hit points, when we're going through this, if everyone's at full hit points, we'll never select anybody. So we could get out of here and just have them flash. That would be a bummer. So how about we do here? So we'll do a if attack target equals no one. This is stupid. This is stupid. We'll put that there. Well, then we don't need the else at all, do we? So, yeah, if the intelligence check is greater than 10, we'll do all of this stuff. If we make it through all of this and don't have an attack target, or if we fail the roll and don't have an attack target, in either case, we'll just choose one randomly. There, done and done. Great. Awesome. Screen check out of here, and let's make sure it works. So, hopefully we can get in there and see some new decision making. I just realized I have a problem. Target create. Yep, boop, gone. Oh, I was testing some stuff before, and so I set their hit rating to something totally abysmal so that they'll never, ever, ever hit. And as a consequence of that, okay, so Sandy's now hit. Now, we should see about half the time it'll attack Sandy, and about half the time it'll attack somebody else randomly. Attack the north. Okay, attack Sandy again. Okay, so it's working. We watched it attack Sandy twice because Sandy's now the lowest. And we saw it attack somebody else and miss. But if it attacked them and gotten them lower than Sandy, then that would have been the new priority target. So this is all working great. So, that covers heroes that are right by our enemies. But what if they're far away? So we need a system to move our enemies towards our heroes if they're out of their current melee attack range. So, this is going to be a doozy. Let's head back into our AI, into our step, and where were we at? So, find target. So, if attack target equals no one, begin attack, action timer, yada, yada, yada. Right here where we normally flash, we're going to get rid of this, and we're going to have a new state. State equals find move node. This is going to be a doozy. And in the end, it's going to require us writing an A* script and a heuristic. That's going to be tricky. It's going to be long and kind of a slog. This whole thing's going to be pretty rough from here on out. So let's just dive right in. And let's do the bones first. I'm going to type this whole thing out. And it's going to throw some errors because it's going to include scripts we haven't written yet. But let's just knock all of this out at once for the sake of simplicity. So find move node is our next case we're going to do. Break. And then right in this mess here, hero list equals ds priority create. I just realized, have we not? So we made a list. ds list destroy. How did I skip that line? That's the most important line. Target list. ds list destroy target list. Yeah, we made a list. We haven't been destroying it. Let's kill that. That's super important, guys. My bad. Okay, sorry about that. So find move node right in here. This is going to be a lot of code. So hero list equals ds priority create. So what we want to do is if there's nobody nearby us, we're going to store them in a priority queue with a priority of how far away they are from us. So that way we can choose whichever one's the lowest priority. That's the closest one, will go to them. So with oActor, if army equals blue army. Ugh, stupid Skype, go away. ds priority create or add other dot hero list id and then point distance x y other.x other.y, and need another one of those. Cool. So we're just going to go through every actor, and if they're a hero, we're going to add their ID to the hero list we just created, and the priority is going to be based on distance, like I said. So they'll sort of line up in this list closest to furthest away. Great. So now closest node equals no one. While, what am I doing? Closest node equals no one. And this is a while loop. Be super careful with your while loops or you could end up with an infinite loop. We don't want that. If an infinite loop ever happens to you, you'll know because the game will lock up with your cursor over the little spinny thingy. What you want to do is Control-Alt-Delete and then go directly to the game process. It'll be this Yo-Yo Games logo, except it'll be white instead of green. Kill that one. When you kill it, it should kill the game. And sometimes you don't click on Game Maker right away after that. Give it a couple seconds because you don't want Game Maker to crash itself too. But it happens. Infinite loops happen. I had a few infinite loops while trying to make this tutorial, so it happens. Be prepared for it, but be super careful with your while loop. So while closest node equals no one. And what this closest node is we're essentially trying to find some place to stand next to the closest actor, wherever that is. So target hero equals ds priority delete min hero list. And this is going to look really silly, but bear with me. So target node equals map target hero.x or grid.x target hero.grid y for ii equals 0. Oh, so we now currently have the node the hero standing on. We're going to step through that node's neighbor list and look for a free node somewhere we can stand around that hero. So ii less than ds list size target node dot neighbors ii plus equals 1. Great. Current node equals ds list find value target node dot neighbors ii if current node dot occupant equals no one, and current node.passable. So obviously anywhere that we can stand that is occupied by somebody else, or that has somebody else, or that's not a, like we don't want to be a wall, we want somebody else standing there, then closest node equals current node. Great. And then if ds priority size hero list is less than or equal to 0, target hero equals no one, flash equals true, alarm 0 equals 30, state equals idle, break. Great. Okay, so let's go through this all again. We've got a while loop. We set this closest node thing. Who's the closest node, right? So we're essentially looking for not just the closest hero, right? We're looking for the node that they're standing on. So while closest node equals no one, we're going to grab a hero from our priority queue, and we're going to go through and see, hey, is there somewhere around this hero that I can stand on? And if there is, then we set closest node equals current node, we fail out of this, no problem. If there isn't, so we reach the end of our priority list, right? Then target hero equals no one, flash equals true, alarm, we just flash. And that's not great. So essentially this is only going to happen if every single hero in the game is completely surrounded by either bad guys, walls, or other heroes. If you've got that many bad guys and that much heroes and that much stuff going on in your game that this comes up, I don't really have a good solution for you that's easy for me to teach right now, an hour-long instruction block, especially when, ooh, good lord, we're halfway done with an hour-long instruction block. So at any rate, let's hope that this doesn't happen, because all they're going to do is flash. And really, if all they do is just sort of fail their turn out, really, the heroes have their hands full anyway. They're completely surrounded. Not a big deal anyway. So point is, we've got our target hero. Essentially, we're ignoring our target hero. We've got the node that our closest hero is standing on, and that's what we want. So, at the end of this, let's get backed up so we can get to the middle. Let's go to ds. What am I doing? ds priority destroy hero list. We no longer need that. If target hero doesn't equal no one, because we're still running this even if we fail out here. So we still need this if for everything else that's going to come next. Target node equals closest node. I don't know why I'm bothering to do that. AI movement map grid X grid Y. That's the closest node. So this is the script we're going to write, AI movement. It's going to work kind of similar to movement range, only it's kind of like a bastardized A star. Rather than just fanning out in all directions until we hit a number of squares away, we're going to move gradually towards wherever it is we're trying to go until we hit where we're trying to go. You'll understand that once I've written it here in a bit. In the meantime, this is going to throw an error because, well, that's a problem right there. How about I comment him out? So if anything else throws an error, I don't end up with a problem. So while closest node dot g is greater than move times actions, and that sounds a little silly, right? But since A star goes from this point where we're standing to this node, no matter what, it could very well be further away than we're capable of moving. So in that case, we don't want our bad guy to move like 30 squares to get to where they want. We want them to move as far as they can move. So we're going to go closest node equals closest node dot parent. And so instead of moving those 30 squares away, we're going to move the 10 squares that we can move in that direction. Great. Create path. We've done create path before. That's another one we wrote. Pass our own ID. and then closest node. That's where we're trying to go. Great. Why do I have all this target node stuff here and all this closest node stuff here? What's up with that target node? My notes might be wrong. Give me a second. This all works. It's just this line of code might be completely extraneous. If it is, we'll come back and delete it later. So, just going to keep moving on. Create path ID closest node, and then map grid X, grid Y, dot occupant equals no one. So this is typical movement stuff. We're telling them where we're currently standing. What's wrong with this? Assignment operator expected. Up. Regular equals, not equals equals. Okay, we're telling where we're standing that there's nobody there anymore. Grid X equals closest node dot X. Grid X. Grid Y equals closest node dot grid Y. Y, there we go. And then closest node dot occupant equals ID. And then state equals begin path. And we'll reduce our actions. So if closest node dot G is greater than move, then actions minus equal 2. Else actions minus equal 1. Great. 2 more squigglies and a break. Except at the end of this, we want to wipe nodes. Alright, so now looks like I never actually used a target node. That's a piece of artifact code from when I was trying to get this stupid thing to work while I was getting this infinite loops the other day. So there's our find move node. Here's the top half of it. I'm going to leave it for a couple seconds. Go ahead and pause if you want to check it. Here's the bottom half of it. Go ahead and leave a couple seconds. Go ahead and pause if you want to check it. Probably have some sort of errors here. People are screaming at the computer screens right now. Don't worry, I'll find it when it airs out. All right, so now down here, obviously we need a case begin path break, and in here we want a path start movement path because they've still got the same movement path that all of our other actors have. Move speed 0 true. State equals moving. Great. Now, obviously, we have a path and moving along a path, etc. Well, we need an end of path event, so let's take care of that now. Let's green check out of all of this mess. Add event, other, and what is it? End of path, almost all the way at the very bottom. And let's drag in another block of code. And now we want to clear path. Path, clear points, movement path, and then if actions are greater than 0, state equals find target. Great. Else state equals idle, and ogame.current actor equals no one. All right, now let's do some A star. So, let's talk about this real quick. So, path clear points have to do this. If you don't do this, every time they move, they'll go back to where they started, and then move to where they first path ended, and then move to where this path ended. It's like every single time, and it'll get bigger and bigger and bigger. That's kind of cute to watch, but that's not how we want things to work. They have actions remaining. Well, clearly they're right next to the guy they want to be next to. They'll bop them on the nose. Otherwise, just idle out. No problem. Idle out, and of course, increment to the next turn. Let's green check out of here and there, and scripts. Path and range finding. The first thing we're going to type, right, is... Okay, so we're going to do A star. This is going to be pretty similar to our initial pathfinding with one pretty major deviation. Movement range just sort of fanned out in all directions. I kind of mentioned this earlier. And it just adds all neighbors to a list and then going through them all willy-nilly. In our A* script, we're going to be adding another step. We're going to be adding all of our neighbors to the list, but instead of going through them indiscriminately, we're going to be adding what's called a heuristic. That's what this script is going to be. It's going to be heuristic. And what this heuristic is going to do is it's going to compare the XY coordinates of the node we're currently working with the node that we want as our destination. Then we'll add the nodes to our data structure in such a way that it prioritizes the nodes that the heuristic predicts will be closest to the destination node. So in this case, we're going to use a priority queue. And that priority set will be based on the heuristic. So let's start with this heuristic so you guys can see what I'm talking about. So heuristic, and I know that's a terrible name for a script because I have to remember how to type that every single time. I'm sorry. So finds the Manhattan distance between 2 points. If you guys are curious about this, by the way, just Google Manhattan distance. I'm sure you can find plenty about what all that's about. Argument 0 equals goal node. Argument 1 equals our current node. Goal equals argument 0, and node equals argument 1. Now you might be wondering why does this just node? Doesn't he normally call these things current? I do normally call these things current, and that's what was causing my infinite loop. It's complicated. Don't call this current, because the script that calls this is our A*, and it works with current. And so you'd be altering its current with this current, and then next thing you know, all of your nodes, their parents are themselves. And you can't build a path if all of your nodes have their parents as themselves. This doesn't do a lot. It's not going to look very impressive. So temp equals absolute value of goal.gridx minus node.gridx plus the absolute value goal.gridx minus node.grid y. Node.grid y minus, there we go. So we're going to take our goal, grid x, minus the node we're currently working with, grid x. So let's say our goal is 1, 1. So it's right up in the top left corner-ish. 1, 1. And we're working at 5, 5. This would be like, okay, so our goal is 1. So this is negative 4. So 4 plus 4. This would have a Manhattan value of 8, like 8 squares away from wherever it is that we're going. If we were doing the 3, 3, that'd be, okay, well, 1 minus 3, 2, 1 minus 3, 2. That'd be 4. Well, 3, 3 is obviously closer than 5, 5. So 5, 5 has an 8. 3, 3 has a 4. We'll have our code set up to do the 4 first, to prioritize going in that direction. Anyway. Return temp. Okay, so we'll use this the number this function returns to score our nodes for our priority queue. That way, it can always go for the lowest scored number in the queue, which is likely to create the most direct path to our destination node quickly and efficiently. There are some problems with A* depending on how terrain is set up, but for the most part, it's a really solid way to go as efficiently from one point to another on a grid as possible. But now we've got to write A* itself. Now, a lot of this will look pretty familiar to the movement range function that you guys have all sat through already. There's a couple of minor twists and turns here and there. We're just going to push through this. Just trying to get through it because you guys have already done movement range. This isn't that complicated compared to movement range. So let's create a script, and we're going to call this AI movement. Because this isn't really like a good A*. This is an A* that's more than functional for our needs. How about that? So 2 arguments. Argument 0 is the start node. Argument 1 is the goal node. So what node we're starting on to what node we're trying to get to. We're going to start with O node. parent equals no one, G equals 0, start equals argument 0, goal equals argument 1. And let's make this window bigger. It's certainly going to need to be bigger. A lot of stuff to write here. All right, let's get a whole bunch of my usual spaces so I can keep working kind of in the center of the screen. So open equals ds priority create. Closed equals ds list create. Pretty similar so far, right? ds priority add. Open start the priority of 0. And then we want to no, that's unnecessary. Okay. ds list add closed start. All right, so while ds priority size open is greater than 0. And this is another while loop, so be careful with them. Current equals ds priority delete min. So we're going to go from bottom to top, whichever one is the lowest priority to the highest priority. Now here's one of our break statements. If current equals goal, break. So if we reach our goal, we're just done with this while loop. Out of it, because that's where we want to be, right? That's what we're trying to do. So for ii equals 0, ii less than ds list size current dot neighbors. We're going to go through all of our neighbors. Neighbor equals ds list find value. You guys are probably getting sick of doing this by now. Current dot neighbors ii. If neighbor dot occupant equals no one, and neighbor dot passable. So we're only going to do this block of code if we actually can stand there. Cost mod equals 1 if neighbor dot x doesn't equal current x, and neighbor dot y doesn't equal current dot y. So this is our diagonal check. If it's diagonal, then cost mod equals 1.5. Great. Just like we did in the last one. So normally it costs 1 to go somewhere, or whatever the cost is, and if it's diagonal it costs 1.5. Pretty easy. If ds, wait, what am I doing? Temp cost equals neighbor dot cost times cost mod. Temp cost equals plus equals current dot g. So that's getting our cost set up, all said and done. Neighbor.cost plus cost mod plus our current G score. Cool. All right, so yeah, that's just setting all of our cost up. So if ds list find index closed neighbor is less than 0, so if it's not already on the closed list, or temp cost is less than neighbor.g. So if we haven't already done this stuff, because if we've already done this stuff, it'll end up on the closed list. If we haven't already done that, or if it's more efficient to get to the neighbor we're working with from our current node than it was from whatever calculated it last, then we're going to do all of this stuff. So neighbor.g equals temp cost. Priority equals temp cost plus heuristic. There we go. That's what I'm looking for. Goal neighbor. Great. Okay. ds priority add open neighbor priority. Neighbor parent equals current. ds list add closed neighbor. Sorry for such a long strip of code without narration. I figured I'd just do it all at once. So while our priority size is still open, we're going to grab a current one by deleting it out, and we're going to grab the one with the lowest priority, the one that we think is closest to our end goal. And then if the current is our goal, we're done. We're no longer in this while loop. Goodbye. We're also done with the while loop if our priority queue is done. Either way. Then we're going to step through our current node's neighbors list, all of them. Boom, right? For each one, we're going to check, hey, is there anybody standing on you? Or can we actually stand there? And if we can, then we do the diagonal multiplication. We get the costs all calculated up, whatever it's going to be. And then we go, hey, all right, are you on the closed list? If you are, never mind. Or actually, if you're not on the closed list, then we're gonna do whatever. And even if you are on the closed list, if it would be more efficient to get there from whatever node we're currently working on than whatever node put them in the closed list, we're going to recalculate all that stuff, add them to the closed list, and then add them to the open list that we know to explore in that direction as well. Great. Awesome. So that's the bulk of it. Now, unfortunately, this little double check, this part, this temp cost less than neighbor.g, right? This is an important part of pathfinding to make sure, like, well, wait a minute. Maybe they got there in some weird, squirrely, roundabout way. And if so, then that's not doing us any favors. We want an efficient way to get there. And this if current equals goal break could stop us from being able to go back and recalculate everything. So what we actually want is a second while loop down here. And this is going to look a little squirrely, but just trust me. While ds priority size open is greater than 0. So we're essentially just going to keep going through the, like, if we break out, if there's still things left in the open queue, we're going to keep going through it anyway to finish calculating everything else. And we're going to do it a little bit differently. So neighbor, what am I doing? What am I doing? Current. Gosh. Current equals ds priority delete min open priority delete mind. Delete mind. Like, I don't know. Some sort of cheesy 60s sci-fi villain. Delete mind with my mind ray. For I equals 0, I less than ds list size. Guess which list? Current.neighbors. I plus equals 1. Neighbor equals ds list find value current.neighbors. I said you guys are probably really sick of typing that by now. I don't blame you. I sure am. If neighbor.occupant equals no one and neighbor.passable cost mod equals 1.5. Gosh, this goes here. Temp cost equals neighbor dot cost times cost mod. Temp cost plus equals current dot g. If ds list find index closed neighbor. So we're checking the ds list for this thing already in there, less than 0. And of course the ds list find index, it returns -1 if it can't find something on a list, and it returns 1 otherwise. So if it's less than 0, then it's not on the list. Or temp cost less than neighbor.g. Then we're going to do some stuff. Neighbor g equals temp cost. Neighbor parent equals current. And ds list add closed neighbor. All right, so at this point, the main difference is that we're no longer expanding the open list. We're just sort of going back, give everything a once over, and we're like, hey, is it easier to get there from here? All right, good, done. Now we're done. All right, we're about at the end, so let's close this out. Let's pop open our room and add a couple more bad guys. So let's go into room 0, objects. And where'd he go? Oh, actors. Target. Now let's put them in some squirrely places, right? We want to see if our pathfinding algorithm is really working all that decent. So let's put a guy there, put a guy down here. That way there's kind of like, there's no line of sight. They kind of got to go squirreling around. Let's just, that's fine for now. Green check out of here. All right, so our basic AI is all ready to go. Hopefully. I'm going to click run, and assuming there's no errors, that this is the moment that we've all been waiting for, right? This is what we've wanted since the tutorial started. We're finally going to have bad guys that move around on a grid and do bad guy stuff. So let's fire it up, and let's hope it works, and we can see some of the fruits of all of our hard work. Like probably a couple 100 hours worth of work on my part, but it's been several hours worth of work on your guys' part too. So it says moving, but he's not moving. This is debug information I typed in because I was having problems before. Why isn't he moving? Well, he made it all the way to moving without moving. So clearly there's something wrong here. What is it? Okay, well, the bright side is the game isn't broken, so I can close that. So something's gone terribly and horribly, inexplicably wrong. So we made our state to moving. Begin path. Path start, movement path, move speed 0 to. We did create a path, right? If target hero does not equal no one. Great. Otherwise, it should already be blinking. I don't need that target node, do I? Huh. Oh, gosh. I forgot to uncomment out AI movement. I've just ruined everything. Like our big moment, I ruined it by leaving a couple comments there so it wouldn't throw an error at me. Okay, gosh. I should edit that out. All right. So this is the moment we've all been waiting for. I'm not going to move anybody. I want them to come to me. Error. Damn typo. Line 64. All right. AI movement line 64. If neighbor.occupant. Bright side is that was at the end of AI movement. So, all right. There we go. All right. We've got our guys going. Excellent. And they're all moving. Look at them. Look at them go. All right. And if we keep going, they're just going to keep beating on our dudes. Uh-oh. They killed Sonny. And like I said, and of course, if I move, they'll react to me. Who is this? It's Danny's turn. In fact, let's get Danny out of there. Poor guy's getting beat up. Let's go ahead and kill that one. Boom. And have her move away too. Now if they're going for Sonny, because Sonny's the closest, or Rizzo. Sonny or Rizzo. Anyway, point is, it works. Awesome. So, if you're enjoying the tutorial, be sure to like or subscribe below. Thanks for watching, everybody. I'll see you next time.